Am I on? Okay. Hi, everybody. So this video is going to be the last in our data unit. So for this week, assuming that you're following along with my online assignments and not just watching this for the paper packet you might have received in the mail, this is the only new lesson that we're going to have for this week, and then you are going to have a summary assignment. So it's a Google form kind of escape room thing if you're doing it online, and if you're doing it on paper, it'll still be those escape room questions, and you'll still have to find the codes to unlock. But that is kind of your summary of all the things we've been working on for the past 4 weeks, including this lesson. So you will just have this one lesson this week and 2 IXL skills to go along with it. Make sure on the assignment page that I send out, the outline, that you're paying attention to the scores that you need. General, you need an 80 on both of the skills. Advanced, you need a 100 on one of the skills. So make sure you're paying attention to that. Again, doing both IXL skills, not just one. If you follow along with your own notes with this video, you don't need to turn these notes in. They're just for you to have to use as you're working on your assignments. And then if you do the worksheet instead of the IXL skills, again, that's totally fine, whatever works best for you and your family. But if you could try your best to upload those worksheets in Teams, that makes it a little bit easier for me to kind of keep everything organized and know where to find it. If you're doing the online stuff, you don't need to turn anything in on Teams. If you want to press a button and let me know, like, hey, I did the IXL skills, then that's fine too. So just make sure if you have any questions on what should I do, what should I turn in, ask. I'd rather you ask before and be 100% sure than not know, guess, and then I have to reach back out to you and be like, hey, you didn't do the right thing, or there was some confusion here. Okay, so never hesitate to reach out to me. Literally, that's what I'm here for, is to help you guys. So we are going to get started on our last lesson. It is on histograms, not to be confused with Instagram, but histograms are, I hope you can see that lime green. Okay. I don't know if you guys have noticed, but I've color coded all of my lessons. Typical for me. Histograms are a type of bar graph. So if you did your Microsoft check-in form, that's why I asked what you know about bar graphs, because we're going to learn a specific type. The bars in a histogram are going to represent the frequency of numeric data within intervals. And so we're going to talk about what those two words mean as well. The frequency is the rate at which something occurs. We've talked about this word before, but just to make sure that you understand, it's basically saying how many times did something happen. And so for a histogram, excuse me, we're talking about data, so we're going to be asking how many times did a data value happen. So kind of like what we talked about with the dot plots and the mode. An interval is a set of numbers contained between two numbers. So for histograms specifically, our intervals might be from 0 to 4, and then from 5 to 9, from 10 to 14. So that would be an interval. So how many data values happened within that? It's almost like a range, right? You're kind of like your vocal range, like we talked about. What's the lowest and the highest that we want to go for that specific group that we're going to create? So before we get into what histograms are, I do want to kind of review some of the things we've already learned so we can kind of see the difference of why we need all these different visual displays. So a dot plot shows, what was I trying to say here? Every single data value. Yeah. So a dot plot, you can't see that. A dot plot is literally showing, like we did, that was the first one we did, is going to show every single data value, every single one. I don't know what I was trying to say here. It shows, oh, no. data measures. This is what happens when I make the notes, but I don't film the video the same day I made the notes because I didn't feel like looking presentable. So what I mean by no data measures is you can't look at a dot plot and right off the bat know, okay, hey, that's the mean or that's the median. But this is a lie, actually, because it shows, some. Sorry, you guys, it's been a long day for me. Some data measures you can find. I hope you're noticing what you already thought, wait, Ms. McNair, you're wrong. It does show the mode, right? But it doesn't show the mean immediately. It doesn't show the median immediately. You'd have to find it. The range doesn't really show it right off the bat, right? You'd have to do that subtraction. So you could find the range easily with a dot plot. But it does show every single data value, and that's kind of the main point I want to make here. A box plot, so that's what we did on week 5. I assume you struggled with that one. That one is probably, in my opinion, the most difficult one. But a box plot shows, this should say A here, a 5-number summary of a data set. So remember, for the box plot, to make the box plot, all we needed was the least, the greatest, and the median, and then the lower quartile and the upper quartile. So those numbers are data measures, right? That median, that lower quartile, that upper quartile, those tell us a lot about a data set. When I say data measures, I mean, the measures of center, the measures of spread, the things that we've found and calculated to help us summarize a data set, right? Like we talked about from the very beginning, when somebody says, hey, how long does it take you to run a mile? You're not going to say, well, on this day it took me this long, and on this day it took me this long, and sit there and go through all your mile times, right? You're going to kind of find an average or a mean or the mode maybe or the range. My shortest time was this, but my longest time was this. That tells a lot without having to give somebody, here's all my data, right? So that's what I mean by data measures. So with our 5-number summary of a box plot, those numbers are data measures, but they're not always exact values in the data set. Remember, the median doesn't have to actually be the value in a data set if you had 2. The lower quartile and upper quartile, same thing. Sometimes it's going to be an exact value in the data set, but sometimes it's not. If it was 77.5, I feel like that was one of the lower quartile or upper quartiles we might have had, but that didn't mean that 77 and 5/10 was in your data set, right? And so a histogram, maybe if I move my little video. Nope, didn't want to do that. I think that might be better. Okay. My dot cam is in the way. You would think by week 6 I'd have this figured out. A histogram shows how many data values there are. So with the box plot, remember, we're only showing those 5 data values. So we have no idea if there were 20 data values in the data set to begin with or just the 5. A dot plot, there's a dot for every single data value. So we definitely know every single data value in the data set. A histogram is going to show how many data values there are. We're going to know if there were 20 in the data set or 50. But it's not going to show us but not each value or data measure, I think is what I meant to say here. I really should make a key first and have that on the side so I can cheat because I really forget some of the stuff I was trying to say. So a histogram shows how many data values there are. And when we make it, I'll show you where you can tell if there were 20 or 50 or 5 data values in the data set to begin with. But you're not going to know what each specific value is because, like we said before, we're just talking about how many data values happened within the interval. So if my interval is 0 to 4 and we know that there were 7 values that happened in between that interval, those could have been 7 zeros. It could have been 1 0, 1 1, 2 3, so on and so forth. We're not going to know what each specific data value was. We're just going to know how many of them there were within that set range of numbers that are in our histogram. And so because of that, it's also not going to show us any data measure. We're not going to be able to know the mode, the exact mode. We might know, okay, well, the most number of data values happened within this interval, but they could have all been a different one, right? There could have been just one each for that interval, so we're not going to know which specific data value occurred the most. For the range, we're not going to be able to find that because we'll know the greatest of the greatest interval, but that doesn't mean that a data value was that number. We're going to know the least for the smallest interval, but that doesn't mean that that data value was that number. So we'll have like kind of a guesstimate of the range, but it won't be exact. And then if we don't know the exact values, we can't find the median because we can't put them in order from least to greatest. We can find a guesstimate of the median. We'll know which interval is the median, and we'll talk about that too. We definitely can't find the mean. We're not going to be able to add up all our values because we don't know what they are. And so I know maybe some of the things I'm saying might not make a lot of sense right now because we haven't made a histogram. You haven't seen what it looks like. So come back to this part of the video after we've made some histograms if you're still kind of confused on, wait, why can't I find the range? However, all three visual displays, because that's what these three guys that we've learned are, do show how data is distributed. And we've talked about that word quite a lot now. Remember, distributed means how data is spread out. And so the dot plot showed us how much data was spread out, because if it was like, ooh, and then it went there, if it was a lot over here, and then a lot over here, the box plot showed us really clearly how data was spread out. If all of our boxes and whiskers were close together, all of our data values were close together. If our whisker, our lower quartile whisker, and then our box, and then our box, and then our upper our greatest was like way out here, we knew that that was probably an outlier, right? And so a histogram is also going to show us how that data is distributed. And that's kind of always something that you're going to look for when you're looking at a set of data. How much is it spread out? You know, thinking about some of the data sets we've looked at, test scores, right? We said that if test scores were spread from 50 to 100, there's some misconceptions there, there's some misunderstanding, something needs to be done, right? Whereas if our test scores all range from 70 to 100, we did better. From 80 to 100, we did a lot better, right? Same with maybe race times, if we're talking about running a mile. If those times are really spread out, that says a lot about the team, close together. Thinking about scores for a team, basketball, football, baseball, you know, if all those scores are close together, that team's pretty consistent. So things like that. I'm sure some more examples will come to my head later, and I'll blurt them out. If you have any other ones, I would love to hear them. All right, page 2. Well, I'm so tired of this video. Okay. I'm going to scoot it over on this side. I don't think that's any better. Hello? Okay. Let's try this. Let's see how this corner works. I think this is how I started these videos. All right, so example, members of a basketball team attempted free throws. They attempted 50 each, and the number they all made is shown. So this is their data. So one player attempted 50, he made 42. He's pretty good. So on and so forth. So the first thing we are going to do is create something called, hard to see over my whiteout mistake there, a frequency table. And then this is going to group our data into intervals. A dot plot can be helpful here. So when we're talking about how many times a data value occurs within an interval, if you're just going straight from the data set to the histogram, you're going to be fixing your bars over and over and over again, and you're going to get a little confused. So it's helpful is to kind of go ahead and make a separate table, frequency table, that's what this is, to show how just to know right off the bat, okay, there's this many numbers within this interval. There's this many numbers within this interval. And then you just draw your bars to represent those heights. The reason I say a dot plot can be helpful is because if we're looking at what our intervals are, then we can just kind of block those off on a dot plot and then just count the dots, opposed to trying to like keep track of the numbers. And so you don't always have to draw a dot plot. If you find another way that makes more sense for you to create your frequency table, by all means. I've seen people do tallies, and so I'll do that on another example. But I know a lot of you like the visual of a dot plot, so that might be helpful for you. So 42, 25, 29, 39. I probably could have drawn these dots a little bigger. 44, can you see them? Ah, you can see them. 33, 30, 29, 35, 36, 34, and 35 again. All right, so there's my dot plot. I thought of something while I was making that. I will most likely make a mistake in this video. I've made one in every single one so far, and somebody's pointed out to me. Go back and look in the description of the video. That's where I'll let you know what my mistake was. So make sure you're paying attention to that. If I do something and you're like, oh, wait a second, call me out. It's okay. I'm human. I make mistakes. A little stressful doing all of this, so sometimes I will definitely overlook something. So I hope you see that when we make this dot plot, everything's kind of spread out, so we can see our least and our greatest, and we can see that, you know, there wasn't any, I mean, we've got two modes, 35 and 29, but it's kind of hard to see much else, you know, everything's really spread out. A dot plot doesn't really do the best job of representing this data set. So that's where a histogram might come in. So for our intervals, if we're looking at the data values we have, let's do 20 to 29. And then the next number we're going to need to start with is 30. So be careful here. We're not going to do 20 to 30 and then 30 to 40, because then if you had a data value that was 30, which interval would it go in, right? So we're going to do 20 to 29, and that is actually 10 values, right? If you count 20, because we're going to count anything that is a 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So our interval is 10 at a time because we're counting the data values. We're not looking for that range. So that's kind of where an interval is a little bit different than a range. So be careful there. So then the next one, though, would be 30, and we'll go to 39. Yes, we love the Dora Explorer vibes. Okay, and then 40 to 49. Cool. So like I said, a dot plot can be helpful because now if we're doing 20 to 29, we know that 20 is down here. I'm just going to stop it. Just going to kind of block it off, right? And then we'll have 30 to 39, and then 40 to 49. And now for my frequency, I just have to count how many dots are within each of these intervals. So for 20 to 29, we've got 1, 2, 3. For 30 to 39, 1, 2, 3, 4, 5, 6, 7. And for 40 to 49, 2. So now if you didn't have the dot plot, I still know how many data values there were. 3 here, 7 there, 2 there. That makes for a total of 12 players. But we don't know if these 3 data values were all 20s, a 20, a 25, and a 29. All 29s, we don't know. So that's one of the biggest differences with a histogram. I guess you've seen that. So something that I encourage you to do when you're doing these frequency tables too is to make sure that you've got all of your data values. It's literally just counting. So going back to the original data set, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And like we said before, 3 plus 7 is 10 plus 2 is 12. So I know that I didn't miss any data values on accident. All right, I'm going to move me to the other corner. There we go. So for our frequency table, we're going to turn that into a histogram. Most of the histograms you have or are going to get are already going to have your labels. I didn't label this one so that you can see kind of what each label means as we label it together. So you're going to draw a bar to show the frequency of data within each interval. Literally the definition of a histogram, right? Ooh. Okay. Couple things about the histogram. All right. Got axis here because we've got a bar graph, so we're going to have a horizontal line and a vertical line. We know our horizontal line is our x-axis. Good. So our vertical is our y. On our horizontal x-axis, we are going to list our intervals. That's kind of where you would list. Our intervals are basically our categories, right? So that's kind of where you would list your, like if you were seeing how many friends like each color or something, that's where you'd put those colors. And then if our intervals are on our x-axis, our bars are going to show how many there are, how high it goes. And so that's going to be our frequencies. And I am noticing something, so I'm going to pause the video for a second, and then when I start back, just letting you know there's going to be a little cut real quick. Okay. I'm going to have my little ring light thing, but I feel like I was too dark in the corner there. Okay, so our intervals, this is where we're going to list our 20 to 29, 30 to 39, 40 to 49. We're going to do it one way here. On the next example that we do, there's a little bit of a different way that it can be notated sometimes. So just pay attention to that. So I'm just going to 20 to 29, 30 to 39. Can you see that? Okay. 40 to 49. And then our frequencies, we've got 3, 7, 2. So looking at our bars, I'm just going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not always going to count by ones. Sometimes it's going to count by 2s or 4s or 3s or depending on 10s, depending on what your data looks like. So now, when we draw the bars should have equal width. And what I mean by that is we're not going to draw one bar really skinny and then one bar really wide, because then it's going to look like there's something different with that data there. You know, why is that one skinny? Why is that one wider? And that's something in other kinds of our graphs that might mean something. So we want all of our bars to be the same width. And then we also want our bars to touch but not overlap. And so that's one of the biggest differences between a histogram and then any other bar graph is that our bars in our histogram are going to touch each other. They're just not going to overlap. And so that's going to point out sometimes that if there is a bar and then not a bar, there's no data values within that interval. And so if we keep them all spread out like a normal bar graph, if we were just looking at how many people like blue, how many people like pink, how many people like green, it doesn't really matter if those are all spread out. You know, it doesn't matter if those close together or spread out. It's not going to kind of make a difference with the data. Whereas we're talking about intervals here, if there's space in between, it's going to look like there's an interval that's missing some data values there. So we can make our bar graph now, our histogram, excuse me there. So for 20 to 29, I'm going to get a different color here just so you can see the different bars. We're going to go up to 3. So we're just going to literally draw a bar up to 3. And then I'm just going to shade it in a little bit for a little spice. For 30 to 39, this one's going to go all the way up to 7. So again, they're going to touch but not overlap. So they're just going to kind of like share a side. And we need to go up to 7. I'm going to try and make it the same width. There we go. It is a little wider, but again, like I always say, I don't teach art. And 40 to 49, 2. So up. And there we go. That's our histogram for this data. And so now we can see a lot more clearly here than in the dot plot that a good chunk of our basketball players made within 30 to 39 of their attempted 50 free throws. That 40 to 49 was the least. Again, we don't know what the least value is. We don't know what the greatest. We don't know if somebody made 49 or if the most that was made here was actually just 40. But this kind of, because there's so many data values, and so histograms are going to be used. There's not a lot of data values in this data set just because we're actually making it together, and I'm trying to explain a lot of things as we do that. But a lot of histograms are going to use a lot of data values because, especially thinking about having a lot of data values on a dot plot, wouldn't it be very helpful to just have a dot plot covered in dots? Then you can't really see much, whereas a histogram is going to show a little bit different about the data distribution. So we're going to do one more example. This video is probably going to be way longer than it needed to be because I'm having so many technical difficulties and I'm talking too much. What is new? All right, last example. Kim started rating each movie she sees on a scale from 1 to 10. Her ratings so far are below. And so for this one, I'm not going to make a dot plot. I'm going to show you another way that you can organize your data before making your histogram. I can't stress it enough. Please organize your data before making your histogram. Do not just go to the histogram. You need a frequency table. Organize your data before you make your frequency table so that you don't miss any data values. It takes an extra minute, and it's worth it in the end to know that you're sure that you did it right and didn't miss anything. So for this one, I'm just going to put them in order from least to greatest. And so we should be really good at that by now. We've been doing that since the start, but that's going to be helpful here. So 1, feel free to fast forward a little bit through this part, but stop at the right spot. 4. And then this is kind of where, again, I'm going to say that a dot plot might be easier just because you can do the dot plot in the order that the data is given, right? I would have done 6, 9, 8, 5. So putting in an order from least to greatest sometimes can be a little bit more tedious just to make sure you don't miss any values. Okay, there's a couple 7s. 1, 2, 3, 4 8s. She is a generous movie rater. 9 and 10. All right, I'm going to count my values, make sure I didn't miss any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So she rated 15 movies. So again, when we make our histogram, we're not going to know what her ratings were exactly. We'll know the intervals, and we'll know that she at least rated 15 movies. That is something we'll be able to tell. So I already did our intervals and our frequencies for us. I already drew the bar graph. I told myself that I was going to do a different one here. So I'm just going to fill that in. So it's going to say 1 to 2, but maybe over here it'll actually say 0 to 2 to 4 to 6 to 8 to 10. And then those would be the only numbers on your x-axis, on your frequency axis, and or your interval axis, excuse me, and it wouldn't actually show, okay, this is from 1 to 2. You would just obviously know anything past this is greater than 2, anything less is less than. So write those in on your notes too, so you can see. Sorry that I forgot that even when I was making my notes. All right, so 1 to 2. Again, now we can look at our number list, and I'm still going to kind of group them off like we did with our dot plot, but now it's just the numbers instead of the dots. So 1 to 2, there is only 1. For 3 to 4, there is 2. And I told you some people might go through and instead of even putting this in order from least to greatest, I don't think I have another example. No. They might just do a tally, so you'll see that too, like they would have done 6, and they would have tallied in 9, tally 8, tally 5, another tally 7, another tally 4, and kind of done it like that. Well, now I might as well finish that, otherwise that's going to be confusing. 8, 8, 3, 7, 8, 7, 5, 1, 10. Let's see if our numbers match our tallies. But that's an option too. Instead of putting it in order from least greatest or doing a dot plot, you can just do the tallies if you know how to count those and keep up with those. I recommend tallies and not numbers. Your numbers might get confusing. Is that my number? Is that my data value? Is that my frequency? What am I doing? Okay. I'm getting very sidetracked today. I think I had too much coffee. 5 through 6. So 5 through 6, so 3. Good. 7 through 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. And 9 to 10, we've got 2. Cool. So lots of different ways for you to double check and make sure that you've got all your data values. We could add these. We have 15 movies. Let's double check. Double check. Double check. Let me say that 12 more times. 7 plus 3 is 10. Plus 2 is 4, 12, 13, 14, 15. Good to go. 15 movies. All right, for our frequency table, we're going to turn that into our histogram. So remember, equal with bars, touch but don't overlap. So from 1 to 2, we need to go up to 1. Here, we're counting by 2, so we know that 1 is going to be right in the middle. So we'll start here and in there. 3 to 4, there were 2. So I can take that up to the bar. 5 to 6, there were 3. So now we're going to come up halfway. 7 to 8, we're going to go up to 7. So halfway between 6 and 8. Big jump there. Sorry for that. Very loud. And from 9 to 10, back down to 2. And so these intervals honestly can be a little confusing, like does 2 go in here or was 2 in here? So the ones that we drew in the 0, 2, 4, 6, 8. So normally they wouldn't be used for intervals that are so close and so small. But just make sure, even if this is all they give you, when you draw your bars, you can always list these intervals down. I think these are a little bit more helpful for us to see. It's kind of like exactly how you would do colors or movies or, you know, the kind of bar graphs that you dealt with in the past. So the last thing we're going to do for this video, for this lesson, is talk about what can we pull from a histogram, right? No point in making a histogram if we don't use it to analyze anything. So we're going to answer some questions about this histogram. So how many movies has Kim rated so far? How many times am I going to do notes without you being able to see them? All right, how many movies has Kim rated so far? We've answered that a bunch because we can look here even and see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 movies. Which rating or ratings does she give more often? Well, we definitely can't see which singular rating she gives most often, but we can tell that she definitely rates between a 7 to 8 the most often because it's the highest bar. So again, it's the interval mode, but we don't know the specific single value mode. What is her average? What is her average or mean rating? We don't know. Can't tell. Can't tell that from this. If we said typical, then maybe we could say 7 to 8. A mode could be a typical value depending on the data set, but we don't know what her average rating is at all. We don't know what these values are here. We could go and find it with the data set that you can't see, the data set, but the whole point of a histogram or visual display is to not need that list of numbers. So for the last piece, I went ahead and drew a histogram. I'm going to move my video so you can see. I look silly with the little ring lights on my glasses. So I went ahead and drew a histogram so we can just talk more about analyzing it. So we've got some math test scores. How many students tested? So that's where we would need to look at the height of each bar. That's going to tell us the number of students because this right here is the scores. This is our frequency. So we've got 4 to 8, so halfway between 4 and 8, so that's 6. That's 12. That's 22, and that would be 34. So for this, we're literally just going to add those values. So I will write that over here on the side. So 34 plus 22 plus 12 plus 6. We know 4 plus 6 is 10, plus 2 plus 2 is 14. 3, 4, 5, 6, 7. So 74 students. Didn't give myself much room there. What was the highest score? We don't know. We don't know the exact high score. We do know it was somewhere between a 90 and a 100, though. But that's the most we can tell. What's the range of scores? Again, we don't know exactly the range because we don't know that somebody scored exactly a 50 or exactly 100, but we can say from 50 to 100. So normally when it says what's the range of something, we would give one single value, right? 50. 50 points was the spread of those test scores, but we don't know that for sure. This could be 59. This could be a 90. That makes it the range 40, 41. And that's a lot less, right? 31? 31. 31. It's a lot less than 50. So from 50 to 100, can't be sure. We'll put that there just so when you look at this later. How many students earned at least an 81? So we do know that because of what we said. 81 is going to be on this side, and that's why, again, why we said this can be a little bit confusing. So we're going to say this is from 50 to 59, 60. So I'm going to actually write that. 50 to 59, 60 to 69, 70 to 79, 80 to 89. I don't know if you can see this over my whiteout. 90 to 99. So we don't even know that anybody got 100. So let's change that. You can see that. How many students earned at least an 81? So that means the 81 is the least that we're earning. So this is a weird question because here 81 would be in here, and we don't know if these were 81s or not. So maybe if we said how many students earned at least a 79, we can look at that. I'm a mess, you guys. 6, none, 12, 18 students. Yeah? Cool. Which range of scores was earned the least often? This is something we can't answer because it's going to be the smallest bar, so 60 to 69. If we wanted to know the most often, that would be the tallest bar, and that would be 90 to 99. So that's all we can kind of take as far as like quantitative data goes. Quantitative answers, that means answers that are numbers, right? We could say, you know, if somebody says, typically did students do well, we could probably say yes to that because you can see the scores going up. Most students got a higher grade, the lower, you know, it got higher. So I would say that this was a successful outcome of test scores for this. It would just be these 6 students that maybe need a little bit extra help, and that's okay. So a histogram definitely doesn't show as obviously the spread of data, but it definitely still shows how it's distributed. Again, we don't know each single data value, but we do know how many data values there were. And so then just when you're making your histograms, make sure you're paying attention to your intervals and your frequencies. Use those tips I told you about with your frequency table, either making a dot plot, listing them in order from least to greatest, or making tallies. And then when you're interpreting your histogram, hopefully I did not overlook any of the questions on your worksheet. IXL should be good, making sure that if it's asking about a certain range, at least means at. You guys, I answered that wrong. I told you I was going to make a mistake. At least an 81. How do I wish there was a way to rewind this video. So no, and 81, that can stay because we do know at least means that's the least. 81 would be in this, so we can say from 80 up, and that's 22 plus 34, which would be 56. To all the parents watching, I'm sorry. Yes, I do make mistakes like this in class, but I own up to them. My kids call me out, and we work together, and that's why math is awesome, because we can admit our mistakes and learn from them. Cool. So at least means that is the least. We want to know what's more. So how many students earned at most an 81 or a 79? I guess I could have fixed that. That would have been 18. Sorry about that. I'm going to end this video before I make any more mistakes. Reach out if you have any questions, you guys. I hope this was helpful. Bye.